Welcome everyone. In this video, I will introduce the risk of antimicrobial resistance and explain why understanding the bacterial envelope is so essential for developing new strategies to battle bacterial resistance. As said by wise people, knowing more about the physiology of bacteria is the key for success. But first, let's look at the threat we are facing. It is estimated that more than 1 million people die every year due to antimicrobial resistance, and this number is expected to rise sharply, causing a major medical threat. Furthermore, antimicrobial resistance carries a great financial burden, estimated to be tens of billions of dollars annually in the US alone. Looking at the history of antibiotic resistance, it is clear that bacteria always find a way to evade, cope, or get rid of every antibiotic developed. In some cases, resistance was observed immediately after the introduction of a new antibiotic to the market. However, pharmaceutical companies are reluctant to develop new drugs due to the high development costs. In order to cope with this threat, we have to find chinks in the bacterial armor, and one of the most important compartments related to AMR is the bacterial envelope. The cell wall is the target of many antibiotics, including the first modern one, penicillin. Moreover, the cell membrane is also a good target. Importantly, the envelope is involved in many resistance mechanisms, such as reduced permeability, expression of efflux pumps, and changes to membrane components. In that regard, gram-negative bacteria are often considered more problematic. Their envelope is unique and more capable of preventing antibiotic influx. As a result, the majority of death-causing resistant bacterial pathogens are gram-negative. Thus, it is important to understand the roles and properties of the gram-negative envelope. This compartment is made of 3 key layers: the inner membrane, which you can see here, the cell wall, also called the peptidoglycan, and a unique outer membrane. The composition of the envelope is heterogenic, and it contains various proteins essential for its functionality. The envelope itself serves as a selective permeability barrier, but also supports the cell shape. Many virulence factors are embedded in the envelope, and therefore it is crucial for pathogenicity. Taken together, it is now clear that further exploration of the envelope is fundamental to the effort of battling antimicrobial resistance. So, going back to our initial goal, we can now say more clearly what we need to do. Of course, preventing development of AMR is crucial, and that includes proper use of human patients and in farming. However, in parallel, a major research and development effort is required. Discovering new antibiotics, possibly targeting the cell envelope or reducing the envelope's capability to make the cell resistant. The development of narrow-range antibiotics which target specific species. This specificity could very well be based on the structure and composition of the envelope. And finally, antibacterial vaccines are an excellent means to fight AMR. In that regard, surface-exposed elements are the obvious candidates for targeting. So, although bacteria are extremely resilient organisms, knowing their physiology will hopefully give us an edge. Thank you very much for watching. Goodbye.